Let's talk by what it was that made these basic attacks successful. And of course, by basic attacks, I'm talking first of all about error-based SQL injection. And one of the things that we saw earlier on in the course is that for error-based injection to work, we need to get SQL errors. So we need to get errors from the underlying relational database management system to bubble up into the browser, because it's those errors that actually contain the useful information. So remember how we did things like tried to compare an integer to a string, and then there was an exception saying that the string could not be cast as an integer, and the string was very kindly returned in the exception. So that makes things really, really easy when the database server is actually telling you what's going on. And all we had to do was just structure the queries in the right way so that the errors contained the right information. So that was error-based. Next up, we looked at union-based injection. And this was really dependent on being able to append our result set as an attacker to the existing result set that the web application was returning. So we had to do things like get the number of columns that the statement returned correct, and also make sure that the data types lined up. But that wasn't hard to do, bit of trial and error. And what it ultimately meant is that the web interface contained all of the data that we wanted to grab out of the system. So for example, we looked at how we could pull out a list of tables from the sys.tables table. So that allowed us to go through this sort of internal schema discovery process. So union-based injection, very, very easy for pumping results out to the interface. Now again, both these attacks are considered basic in the spectrum of SQL injection attacks. But what happens when neither of these options are available? So what happens when there is no internal error returned to the interface? And what happens when there is no result set that we can just append our own result set onto as an attacker using the union statement? What do we do then? Let's have a look at what the criteria are for making a blind injection attack successful. There's not really a lot required to make a blind injection attack successful. All we need is this. So long as the attacker can manipulate the query that gets executed in the database, it doesn't matter that there's not errors returned to the screen, and it doesn't matter that you can't union one result set to another either. All you need to do is be able to manipulate that underlying query. And what we're going to do in the blind injection attack is infer things based on the nature of the query and the response of the web app. As we progress through this module, you'll see that inference plays a really, really critical role. So we're going to try and make the web app behave in a certain way that's usually going to give us some insight into a question that we're asking based on the payload we're sending the web app. That'll make more sense as we jump into it. Suffice to say at the moment that we're not going to get crystal clear results like we did earlier on. We're going to have to make some assumptions and particularly make sure that we ask the web app the right questions. To demonstrate where we're going to need blind injection, let's go back to our sample vulnerable app, and I'll show you a spot in there where we just simply can't use error-based or union-based injection. And that's the spot that we're going to start probing away with our blind injection.